Okay, in this first problem, you are going to be converting the function that was given to you in factored form into standard form. The first step for that is to take the two binomials together and multiply them. I'm going to use the area model. You are welcome to use FOIL. Okay, so these two are like terms, therefore the standard form of these two binomials is x squared plus 6x minus 16. But we're not done yet. We also have to multiply by 3. So f of x is equal to 3x squared plus 18x minus 48. You lost a point on your test if you forgot to write f of x. Now we're going to write that function in standard form and use it to help us write the function in vertex form. One of the most common mistakes that I saw in this test was that when you were factoring out the leading coefficient of 3, you factor it out from all 3 of the terms, when in reality you only want to factor it out from the first 2. So it looks like this: x squared plus 6x, and then you're going to add something here, but you leave the 48 alone. The 48 did not get factored out. The 48 was not divided by 3. Okay, whatever we add here, we are going to subtract over here. The number that would make this a perfect square trinomial is 9, because 6 divided by 2 squared is 9. And the number that goes here, however, is not 9, it's 3 times 9, because we didn't just add 9, we added 27. And so f of x is equal to 3. The factored form of this is x plus 3, because 3 times 3 is 9 and 3 plus 3 is 6, and we have 2 of them. Okay, notice that this is a perfect square trinomial, right? And so on that essay question that you had at the end, how do perfect square trinomials relate to converting a function into vertex form? This is how, whenever you're converting a function into vertex form, you actually have to create a perfect square trinomial in order to get that form of x minus h squared plus k. The x minus h portion is your perfect square trinomial. Okay, so that's done. We still have to find the vertex. The vertex is you do the opposite of your h value, so -3, but then -75 stays the same. And then the y-intercept, you look at your constant when written in standard form, and that is your y value, your y-intercept, I mean. What is the discriminant of the following function? The discriminant is the portion that's inside of the radical in the quadratic formula, which is b squared minus 4ac. The b value in this problem is -6 squared minus 4 times 2 times 9, 36 minus 8 times 9, and 36 minus 72 is -36. So that is your discriminant. What does that discriminant tell us? Well, first of all, it tells us that there's going to be 2 x-intercepts. No, it doesn't. What kind of x-intercepts do we have? None. They're imaginary. We have 0. And circle imaginary. Why? Well, think about it. We said that this is the part of the quadratic formula that's inside a radical, right? If you put a negative number inside the radical, does that number exist? No, it doesn't. So we have no x-intercepts. You need to fully study this. You can make a tutoring appointment with me, or you can look it up on the internet. You can do whatever you gotta do, but you will not do well on the retake exam if you don't actually fully understand this portion of it. Solve the following quadratic equation. Number 3. Let me go on a tangent a little bit. If you have two numbers, y times z, and I tell you that these two numbers equal 0, what do you know? That y or z must be 0, right? Or even both. Same thing here. You have two factors, y and z. Except that these two factors just happen to be binomials, but that's okay because the two binomials are still being multiplied together, and we know that when two things are being multiplied together and they equal 0, either one of the factors is equal to 0 or both of them. That's why when we have these kinds of problems, we set up two equations. 5x minus 2 is equal to 0, and negative x plus 3 is equal to 0. This is called the zero product property, and you hopefully need to understand it before the end of the year. You add 2 to both sides, and then we will divide by 5. So that's going to give us 2 over 5. And here we're going to subtract 3 from both sides, so we have negative x is equal to negative 3. The saddest thing I've seen on your test is that some of you got to this point and either stopped or you said, oh, this is the same thing as subtracting 1, so the opposite of that is to add 1 to both sides. And that is just super sacrilegious. What's actually happening here is that you have a 1 in front of the x, right? What's the operation between the negative 1 and the x? The operation is multiplication. So the opposite of multiplying x by negative 1 is to divide both sides by negative 1. So x is equal to 3. And it is not okay that you're making this kind of mistake in Honors Advanced Algebra 2. Okay. Panchito is selling Kit Kat bars for a fundraiser. He determines that the profit in dollars for selling each Kit Kat bar at C price can be determined by the following function. Well, right off the bat, I know that this has to be my output because it is the variable in the function that is isolated. There's nothing to the left, there's nothing to the right in front of it. And I know that this has to be my input then. So I will let the C be my x-axis. P of C represents profit, and C represents the cost of each Kit Kat. So what's happening here is that Panchito is selling Kit Kats, right? He's trying to determine the optimal price of selling each Kit Kat for. If he sells it at too much money, nobody's going to purchase it. If he sells it too cheap, he's not going to make enough money. So he needs to determine what that optimal cost is. On your retake, if you just write cost, you will not get any points. You need to be specific because I need to know that you know how to do this and that you know what it means. Find the x and y intercepts and the vertex of this function. I'm going to find the x-intercepts first. I'm going to do this by rewriting the function that was given to us in standard form and set it equal to 0. Why? Because we're trying to figure out what the x-intercepts are, and the x-intercepts will be located somewhere here, which is when our profit is 0. So negative 4c squared plus 24c plus 20. Set that equal to 0. I'm going to divide both of these things by negative 4. Both sides divided by negative 4, so I will be left with c squared minus 6c minus 5 is equal to 0. Next step, I'm solving for c by completing the square, is to move the 5 to the other side. So I will have c squared minus 6c plus something is equal to negative 5 plus something. Okay, why am I writing this way instead of doing the shortcut that we usually do? Because by doing the shortcut, what happened is that a lot of you were not able to see the how perfect square trinomials are connected to completing the square and therefore to solving quadratic equations. What number goes here? The number that goes there is -6 divided by 2 squared, so 9, right? And if we add 9 to one side of the equation, we also have to add it to the other side of the equation. So we add 9 there. What we just created here is a perfect square trinomial. And the factored form of it, so two numbers that multiply together to give us 9, but also add up to -6 are c minus 3 and c minus 3, or c minus 3 squared. A lot of us jump into this step of the algorithm, but as a result, you didn't make the connection that the reason why you're able to do this is because that's a perfect square trinomial and this is the factored form of a perfect square trinomial. And we use the factored form of a perfect square trinomial to solve quadratic equations when we're completing the square on them. We're going to take the square root on both sides. So c minus 3 is equal to 2 and c minus 3 is equal to -2. And I hope I did this correctly. No, I didn't. Did you catch my mistake? Yep, the 5 was supposed to be positive because when you move the 5 to the other side, it becomes, oh, not what I meant to do. There you go. So this is actually 14, not 4. So this is the square root of 14 and the negative square root of 14. Okay. But I need a decimal approximation of the square root of 14 if I'm going to be able to graph this on my plane. So I know that the square root of 9 is 3. And I know that the square root of 16 is 4. And I know that the square root of 14 is between these two perfect squares. If 14 was exactly dead center in the middle from 9 and 16, then my answer would be 3.5. But that's not the truth. The truth is that 14 is only 2 units away from 16, but 5 units away from 9. So again, if 14 was exactly between these two, my answer would be 3.5. But that's not true. Since we're closer to 16, it actually has to be greater than 3.5. I'm going to approximate this to 3.7. 3.8 would have been okay. 3.6 would have been okay. Honestly, even 3.9 would have been okay. I think 3.7 is a good solid answer. So c minus 3 is equal to 3.7. And c minus 3 is equal to -3.7. We're going to add 3 to both sides, and we get 6.7 as one of our x-intercepts, and c is equal to -0.7 as one of our other x-intercepts. So I'm going to go ahead and plot these. So I have my x-intercepts. My y-intercept is just the constant when it's written in standard form, so that's 20. And now I'm going to find the vertex. I'm going to find the vertex by rewriting the equation that's given to me in standard form into vertex form. 1, because I think it's more elegant. 2, if you don't have to substitute any values back into the equation, you are less prone to make mistakes. So we have P of C is equal to -4. Remember, you just factor out the leading coefficient from the first 2 terms, not from all 3 of them. Okay, the number that would make this a perfect square trinomial is 9, because 6 divided by 2 is, well, -6 divided by 2 is -3, -3 squared is 9. And we didn't just add 9, we added 9 times -4, so we have to subtract the -36. Do not screw up the double negative. This one will always be subtract, and if the number is negative, then you're subtracting a negative. If it's positive, then you're subtracting a positive. P of C is equal to -4. Again, this is a perfect square trinomial. Remember we talked about it on the first problem? Perfect square trinomials are needed in order to rewrite a function in a vertex form. The factored form of this perfect square trinomial is 6 minus 3 squared. 20 minus -36 is positive 56. So my vertex is at 3, 56. 3 is about there. And I'm just going to connect my points. Perfect. Letter D. At what price should Panchito sell each Kit Kat bar to maximize his profit? He should sell them at $3 each for a max profit of $56. Okay, lastly, at what price should Panchito sell each Kit Kat bar to break even? That means make no profit, but also lose no money. That would be our x-intercepts, right? He can really sell them at -70 cents each. So I'm looking for $6.70. If he sells them at $6.70, he's not going to make any money, but he's also not going to lose any money. Why do you think that is? Listen carefully, because I'm not writing this part down. If he sells them at $6.70, that price is probably too high to sell as many as he would want to. So he might sell a couple to offset the cost of his purchase. And so he will not actually end up losing any money, but he is not making any money either, because they're so expensive, so nobody is going to really buy them. You can see on your graph here that as the numbers get bigger and bigger, so as the cost rises, he's going to end up losing more and more money. The domain will be restricted in a real world problem. But essentially what's happening is the more money you are trying to sell each Kit Kat for, the less you are going to sell, and so the less profit you are going to make. You're going to end up losing more money given the cost of production or whatever. And I think that is it. I will do the essay part in a separate video.